All right, so chapter 9.1 is almost like a review, I think. It's stuff that we've already kind of talked about, so it shouldn't be too bad. So applications involving, so I mean mainly BU word problems, but they're just for right angles. So applications involving right triangles. Okay. No, so I don't think we need any new formulas. Let's just jump to example 1. Let's see how it goes. Find sine A and tangent A. Given this example, this triangle, I'm going to give this to you in the question. So right angle, 39 is right there, 36 is over here, and then they give you an angle up top. They call it A. Okay. Now, you know what? Let me go ahead and give you this side. So if sine is up there, or sorry, if the angle is up there, then sine A would be opposite to this angle over the hypotenuse. So sine A is still the same, it's just the orientation is different. So it'll be 15 over 39. The tangent, what do you guys think tangent would be? Of A.
15 over 36.
Yeah. 15 over 36. So not too bad, right? This starts off pretty simple, I think. A little bit of refresher from when we first talked about right triangles. It's just that they're going to have different angles to solve and different orientations. So let's do something a little bit different. So use the right triangle to find well, I guess you'd say, let me rephrase that. Use the right triangle and the given info to solve the triangle. Okay, 1 second. Let's see if I have that triangle somewhere. I do not. That's fine. Let's start with something simple. So we're going to find capital A, capital B, and of course, the other angle was 90 degrees. So capital letters will be the angles. The lowercase letters will be the sides and hypotenuse. Here is the triangle, right angle. So we'll call this guy B, this guy A. Capital C usually is there, but we're going to assume that's the right angle. Okay. We don't have that either angle, but I'm going to give you these two sides. So the easiest one to find is the hypotenuse, right? So C will equal to the square root of 9 plus 4, which is root 13. So 13, we'll call A3, B2. All right. Okay, so now we got to find the angles. So we're going to have to use inverse functions. So I'm going to change my calculator to degrees, so it's a little more obvious. Okay. So we know that tangent of A is equal to 3 over 2, correct? So that means that A is equal to tangent inverse of 3/2, which is approximately something. So that should be about 56.31 degrees, according to the calculator. So now that we have B, we should be able to find A, right? Because the sum of all three angles for any triangle is always 180, so A is equal to 180 minus 90 minus the angle we found. So that is approximately something. I'm going to subtract the number in the calculator, not the one I rounded, and then round afterward.
Isn't B equal to that?
I'm sorry? Oh, yes, yes. Yes.
In the 56, you're going A up there.
One more time?
Up above, you have it as B.
Oh, yeah, I don't know why I did that. True. I guess I didn't get enough sleep last night. All right. This is B. This is A. Thanks. There we go. One moment. There you go. Okay. So, and pretty much all of chapter 9, what we're going to do is I'm going to give you a triangle, and you have to find all the missing pieces. Depending on the scenario and the type of triangle, we'll have different techniques. But right now, we are only doing right triangles for 9.1. But most of them will be pretty simple like this. Okay. Let me find another one. Do this guy here. Okay, solve the triangle. Pretty much the instructions every time. Here is the triangle. B, right angle, A. B, A, C. So they say that they don't give us A, They give us B. They don't have little c. Capital A is missing. Capital B is given to be 30 degrees. So what is capital C? Angle. And A.
90 degrees.
Yeah, it doesn't have to be 90, right? So this is 90 plus 30, that's 120. So how much more to 180, right?
60.
Yeah, it has to be 60. And to show our work, in case you're wondering where that came from, it would be 180, the total, minus both of these angles. Oops, that's a 90. Okay. All right, so we got that side. All righty. So now we have to find the sides, right? So we can use either tangent or cosine, don't really matter. We got what? I'm gonna write down 7 here. Yeah, you could use tangent, opposite over adjacent, or you could use cosine, right? Adjacent over hypotenuse. That's whatever. I'm gonna use tan, I guess. That would be opposite adjacent, yeah. So tangent of A would be equal to the missing piece, A, little a, over 7. That implies that little a is equal to, oh, sorry. Oh, that's fine, it's okay. Yeah, so it'll be 7 tangent of 60, right? Because a is 60. I was gonna write 60 here, but I didn't. Let me just fix that. Doesn't really matter, I just want to do that. All right, so tangent of 60 is equal to, we got 60 is up here, so a opposite over adjacent. Solve for a would get you here. Plug that into your calculator and we'll have a. So that will be
exact values.
That would be the exact value. This. Well, no, 60 is a known angle, so we could use the square root stuff.
Yeah, that's what I meant. Sorry.
But the questions and the homework that I picked this out of the homework. It's going to be rounding, so not exact.
Thanks.
I got 12.44.
Yeah, that's right. 12.12.
44.
Sure. They said round to the nearest hundredth, so 10th, 100th. So we'll stop at 2. All right, so we got A now, approximately 12.12. Okay, then. Now that we have A and B, we can find C, right? Using our hypotenuse. Pythagorean theorem. Find hypotenuse. Or we could use cosine to solve for it, right? Using the definition. So we could say cosine of 60 degrees is equal to the adjacent side over the hypotenuse. And if I take the reciprocal of both sides, it's the same as saying 1 over cosine of 60 is equal to C over 7, which is the same as saying C is equal to 7 over cosine 60. You can also do cross multiplication. I just don't like to say that because students like to try to use that for everything, and that doesn't really help. But whatever, it's fine. So 7 over cosine 60 should be about 14-ish. Let's see, yeah, 14. So we got 3 sides, 3 angles. That's how we got to do. So there's my last side.
Excuse me, sir. Where do you get the 12.12?
12.12, make sure your calculator is in degrees, but it would be 7 times tangent of 60.
Oh, okay. Yeah. Okay. Thank you.
Yeah, just punch it in. There's no, if you use a unit circle, I mean, you can do it that way, but a lot of these won't have pretty angles until we get further. Okay, let's do a word problem. A tower that is 57 feet tall casts a shadow 82 feet long. Find the angle of elevation of the sun to the nearest degree. So around to the nearest degree. Okay. So there's some tower. '57 feet tall. And it casts some shadow, right? It's 82 feet tall. And let's say the sun's out here somewhere chilling out, casting the shadow, right? So when they say angle of elevation, that means looking upward. How far is that angle? Right, so if you're standing here, what is this angle that we will call A? Okay. We don't know hypotenuse, so it is encouraged that we use tangent in order to solve for A. So we can say tangent of A is equal to the opposite over adjacent. So then that means, using our inverse stuff from a couple of last chapter, forgot already, that would equal to tangent inverse of 57 over 82. So round that to the nearest degree, and we'll know the angle of elevation. So I got approximately 34.8. So round that to 35 degrees. If there's any question on example 4.
So in this case, that would be the answer, 35
Yeah.
degrees.
Yeah, nearest degree. So you round up to 35.
So it is a tangent inverse 52 over 82. I'm sorry, 57 over 82.
Yeah, so the opposite side to the angle over adjacent, right? Remember, tangent of some angle is defined to be opposite over adjacent, right? So no matter where you put the A, you have to remember where is opposite to that angle. So this one over adjacent, 82. So once you find this, you just use your calculator. Take the tangent inverse of both sides, which gives you A. So A is equal to tan inverse of 57 over 82.
Thank you.
Mm-hmm. I think it's pretty much it for that section. A lot of them are just solve the triangle and then do like a couple of word problems, I think. But I'll look through it, make sure there's no weirdo questions that are too difficult. Anyway, let's start thinking about 9.2. Yeah. Well, maybe there's one more we can do. All right. 9.2. This is the law of sines. So it'll be similar to what we were doing before. It's just that once they are no longer right triangles, you have to use the law of sines or law of cosines. So first, let's go into law of sines, because there's no hypotenuse to solve for, so you can't use Pythagoras' theorem anymore. You have to use this. So here are the two cases, or four, I'm going to give you 4 cases, but only 2 of them you use law of sines, right? All right, so case 1 is one side and 2 angles are known. We call that ASA or SAA. Case 2, two sides and 1 angle opposite to one of the known angles, or sorry, known, rephrase that, 2 sides, and 1 angle opposite to one of the known sides. So basically, if you have 2 sides and only 1 angle, you need that angle to be opposite to one of those sides. In order, otherwise you cannot use law of sines. Okay, so case 1 and case 2, are pretty much going to be for law of sines. Let me double check one thing before I promise that. Yeah. So those first two are for law of sines. Case 3 and 4 are for law of cosines, which we'll talk about in the next section, not right now. So two sides are known. And the included angle is known. Case 4. Three sides are known. We call that SSS. So if you only have sides and no angles, it's law of cosine. If you have two sides, but the angle is not opposite to any of those two, then that's also law of cosine. So 3 and 4 cosine, 1 and 2 sine.
What does case 3 say? I'm sorry, I didn't.
Two sides are known and the included angle is known, best right angle. Included angle is known. All right, so law of sines. Here's the idea and the theory. So for a triangle with sides A, B, C, and opposite angles, capital A, B, and C, respectively, so if the triangle is written this way, and it's not perfect, but it's not isosceles, it's just a general triangle. The only thing I promise that it's not, this is not a right triangle, okay? But if it was, this formula would simplify automatically, but we'll put a little a opposite to capital A, little c opposite to big C, capital B opposite to lowercase b. Okay. So given this formula, the following is true. So sine capital A over little a is equal to sine of capital B over little b. And these three are equal to each other, by the way. You can also flip them over, depending what you're solving for, or if you want to. You could just stick with the top one if you want, but if I'm looking for a side, I usually use this one. So I can avoid less multiplication. Then this will be sine B, and this will be sine C. All right, so let's take a short break and then we'll start some examples. We'll be right back. At 6:44, I guess let's start back up at 7. No, I guess it's, I don't know if I said 705 or 7, but let's get to it. Next example. Oh, here it is. Okay, solve the triangle shown. So in this example, I'm just give you the picture. And because I can't draw, the jaw gonna look the same. This upper angle will be 100 degrees. This lower angle here is unknown. This angle here is 60 degrees. This one's little b opposite to b. Little a is opposite to a. Little c will be given as 4. All right. All right, so as long as we have an angle and an opposite side, see how we have 100 and 4, then we're able to use lost signs. So I'm going to write down all the pieces over here just to stay organized. Capital A, capital B, don't have, oh yeah, I do have that. Capital C is 100, which means that A has to be 20, right? Little a, we don't have it, nor B, but little c is 4. So we need to find these two sides, and that'll be the last of the triangle pieces. So I'm going to use the second one right over here. I'll call this 1 and 2 here. I'm going to use 2 because I need the A's and B's, and they are on the top already. Okay, so I'm going to use that guy. So I'm going to use A over sine A equal to C over sine C. Now, if you multiply both sides by sine A, you can solve for A, right? So this implies that A is equal to sine C sine A over sine C. So you see where this came from? So using equation 2, I set the first and last part equal to each other because they are all equal to each other anyway. So you can do this. And then solve for A in general. So here's a formula for A. Now I can do the same for B. So this will be little b over sine B, because I need to find B, right? That'll be equal to C sine C, which implies that B is equal to, multiply both sides by sine B, to give you C sine B over sine C. Okay, so just plug in everything we know and we're good. We'll have both sides, or yeah, both missing sides. So little c is 4, so that'll be 4 sine of A, which is 20, over sine of 60. 4 sine 20, sine 60. Double check my angles here. C should be 100, not 60. One second. Okay, so plug in what we know. That'll be 4 sine, the sine will be sine 60 on top over sine 100. I hope it's okay that I'm doing both at the same time. Is that weird? And do you see where these pieces came from? Is that confusing or straightforward? Okay. So the first one will be 4 sine 20 over sine 100. So the side will be 1.3. We'll run to 2 decimal places, 1.39. Now let's do this one. 4. Well, go ahead and use the fraction button just to make it pretty. 4 sine 60 over sine 100. So that will be 3.52. So we got our 2 sides. So little b is 3.52. Little a is 1.39. So we solved all the missing pieces of the triangle. 3 sides, 3 angles. Is there any questions on this first example?
No questions.
Okay. Okay, example 2. Let me find an example. Okay. Let me go ahead and give you the 3 angles. And one of the opposite sides to be 2. So I need to find 2 of the sides. Remember, we cannot use Pythagorean. We have to do law of sines for all 3 sides. And since we have an opposite side to one of our angles, then we are able to do law of sines. We don't have to worry about a different method. So I need B. So let's set it up. B over sine B can be equal to, and then you want to use one of these pairs that has both answers. So I'm going to use A and capital A to solve for side A, or sorry, side B. Okay, so then multiply both sides and you get B equal to A sine B over sine A. So let's find out what that is. Plug in our numbers. That'll be 2 sine 20 over sine 40. So that is approximately sine 20 divided by sine 40. So that's about 1.06. I'll do the same for little c. So little c over sine c is equal to, I'm going to use the one that has both. At this point, you technically could use b over sine b, but this one's rounded and this one's exact. So I'd rather use the same one again because this is an exact answer here, or side and angle, meaning I can't get it wrong, right? The rounding will happen after this point. So little c will be equal to a sine c over sine a, which is approximately 2 sine c, which is 120, over sine a, which is 40. Okay, so I got approximately, well, let's go show the numbers. So that'll be 2 sine 120 over sine of 40. That is approximately 2.69. 2.69. Oh man, I screwed the whole thing. And 1.06. All right. Have any questions on example 2?
You were given capital A, right, and capital B.
Yeah, those 3 angles were given. Usually they give you at least 2 angles. But if they don't, then it's a different scenario.
Okay.
Which we'll do next. Right here. Okay, so 2 sides and an angle are given. Okay. So we don't know capital A. We know capital B. Don't know capital C. We have little b to be 7, little c to be 5. All right. So when you're missing 2 angles, there's a possibility of a second triangle or no triangle scenario because we don't know what they are. So when we find A and C, it's possible that there is no triangle. Let me give you a visual of what that means. See if I can find it here. Okay, so when you're finding your angles, right? You see how, where is it? Oh, here it is. You see how the side A can swing out way out here, giving us a different angle for capital C. It'll shift depending on where the A goes. So either it'll come inward or go outward. So this changes side A to have two different scenarios, and then this also changes capital B angle to two different answers. Okay. So if there's two triangles, you'll have these possibilities. If there's one triangle, it'll just be closed and that's it. But it's possible that it's not long enough where the angles do not add to 180, that there is no triangle. Okay, and I'll show you an easy way to check whether you have no, one, or two. Okay. So we'll solve it like normal. We'll just have to double check if there's more than one. Okay. So I'm going to assume I have no idea how many there are. Okay. Now we'll have to use law of sine. So we'll use this one to guide us to solve for the angles. Okay. So I'm going to try to find an angle with capital C here. So I'm going to use sine C over little c equal to sine B over little b. So I'm going to use this part of the formula, and I'm going to solve for capital C, which will be sine C equal to C sine B over little b, which means we have C equal to sine inverse of all that stuff. When you do the sine inverse of both sides, you get this. Or apply a definition, whatever makes more sense. Okay, so we're going to use this formula. So that will be, I'll just do it down here. Sine inverse of 5 sine 140 over 7. That's equal to sine, sorry, that's equal to something. Let's punch it in our machine and find out. A second, sine inverse. That will be 5 sine 140 over 7. So we get an angle of 27 degrees, approximately 27.33. Okay. So we're going to say that there's one angle, C1, equal to 27.33. Do you remember when we were solving for angles, we'd say to find the second angle because of the coterminal side, we'd have 180 minus 27.33 degrees. That would give us our other angle, 152. So basically you have to check if both work or if one works, right? Now look at C2. That's 152 degrees, right? 152 plus the known angle, 140, is way bigger than 180, correct? So right away you see C2 is too big. Therefore, there is only one triangle. Do you see why it's too big?
No.
Okay, so we know for a fact that one of the angles is 140, right? We don't know C, we don't know A, capital A. And we also don't know if there's two A's and two C's because of the whole idea of the angle coming inward or outward. So we find both of the angles, right? And then we check, do they, if I add them to the one we know, is it still less than 180? The 140 is B, right? If I add that to 152, it becomes too large. Do you see that?
Okay. Yeah, that makes sense.
Yeah, because this one's going to be fixed, this angle. So adding that shows you, yeah, there's no way it's possible. If you were to add them together and it's still less than 180, then you can solve for the other A with two different C's. But right now we can't. So it's only one, which is good because when you have two triangles, it's just annoying. If it's just one, then you would do what we've been doing in the last two examples. So nothing changes.
So when you add 152.67 to B, it's greater than 180, so not a triangle.
Put a little extra note here because 140 degrees plus 152.67 is greater than 180. Right, but 27.33 plus 140 is not greater. But that one's okay. So we know the first C is 27.33, which means that A has to be 180 minus 140 minus 27.33. We have the other angle now. All right, so nothing's changed, just like the last time. Now let's find little a, and we're done, right? So a over sine a, I'm gonna use this formula, and I'm gonna use the one that was given originally, so the little b over sine b. Solve in general, little a will be equal to b sine a over sine b. Shit. Yeah, I have no choice to use this angle. Okay. So 7 times sine of 112.67. Go ahead and write that down before I do it. 7 sine of 12.67 degrees over sine of 140 degrees. That is approximately 2.39. 2.39. Okay. So we found two angles this time, and we checked to see if there were two triangles, and there wasn't. Thank God. And we found a little a here. Unboxing ones that we were not given. You guys have any questions on this example?
What does that say on the last part? The 7. Oh, never mind. Sine A. Okay.
Yeah, 12.67. Okay, so we've done two examples where okay. Well, there's another idea here before we move on.
I do have one question. If you find out it's not a triangle at all, do you even have to keep going, or does the
No, you
homework?
would just say no triangle, just stop.
Okay.
Yeah, there's no reason to find sides if they don't ever close. All right, so I didn't mention something. On example 1 and 2, we did not check if there's 1 or 2 triangles or none, because we were already given 3 angles, meaning the triangle existed, right? We were given 3 angles, so we don't have to worry about possible other angles. Same here. If you're given 2 triangles, more than likely you will not see that scenario. Okay. But if you're only given 1 triangle, or 1 angle rather, then you have to, when you solve for one of the angles, you have to check both possibilities. Right? Do they both work or just one? If they both work, then you're gonna have 2 sets of everything. Well, except the one they give you. That one stays the same, but.
Can you move it up just a little bit?
Yeah. So, yeah, the next example, there will be 2 triangles. But you will see that the given angle and side do not change. Okay. Example 4. 2 sides and an angle are given. Determine if there are 1, 2, or none, or no triangle. Oh, dang it. Okay. So we don't know capital A. We do know B to be 20. We don't know C. Oh, I'm sorry. Little b is going to be 9. We don't know C or little c or little a. Okay. So what we're going to do is find capital C like we did before. I'm going to go ahead and call this C1 and A1 here. We're going to have two sets of answers for these angle triangles. So just to be organized, since I'm telling you what's going to happen, here we go. Okay, so I'm going to use the middle one. So these are fixed, so they stay the same. I'm going to use this to help us solve for C1. Let's start with that. So sine of C1 over C is equal to sine of B over little b, which implies that C1 is equal to sine inverse of C sine B over little b. I skipped 2 steps there. Do you see how I got here? Is that right or no?
How does this follow any of the 4 cases?
So we have 2 sides of an angle. So this is going to be
Where's the second side at?
2 sides of an angle. Yeah. Sorry, they did give it to us. I just didn't write it down. Thanks. Yeah, otherwise I would not be able to solve this.
Yeah, I was confused by that.
No, thanks. Yeah, I was about to realize that it's impossible. Okay. But yeah, so we need 2 sides. Otherwise, I think it might be impossible. Let me see. Yeah, you have to have at least 2. All right. So here we go. So that would be sine inverse of 11 sine 20 over 9. So that is approximately, let's see here, 11 sine 20 . So 24.71 degrees. So that is C1. Now, if C1 is equal to 24.71, then C2 would be 180 minus 24.71, which is approximately 155.29. This is where we check, right? 155 plus B, 20 degrees, is still less than 180. So we do have 2 triangles. So C1 plus B is equal to 24.71 plus 20, which is equal to 44.71, and that is less than 180. So great. So C is good. So then check the other one, C2 plus B. That'd be equal to 155.29 plus 20. That would be equal to 175.29, which is less than 180. So those 2 both work, meaning we have 2 triangles. Okay. And once we have 2 angles on both triangles, then we can find both capital A's, right? So A1, so right here I'm going to just box this. checking for 2 triangles. That's what that was for. Okay, A1, that will be equal to 180 minus 20 minus 24.71. So that'll be something. Let's see. 180 minus 20 minus 24.71. So
Sorry.
100. What's up?
Go ahead. C2, isn't it 155.29, not 175 up top?
Yes.
Okay.
Yes. Okay. The sooner you tell me, the better. Thank you. So A1 is still good, right? Yeah. Okay, so there's A1. Now find A2. So that'll be 180 minus 20 minus the C2, which is 155, we say. So that is approximately 135.29, 24.71. Okay. So now we have both A's, both C's, angles, that is. 135.29, 24.71 degrees. Okay, so we got both A's, now we just need the little a and A1 and A2. Okay. So, here we go. A1, little a1 is over sine A is equal to B over sine B, which is the same as saying A1 is equal to, I'll show the work this time, B sine A over sine B, which is equal to sine inverse. Oh shit, wait. No, I don't need to do the sine inverse. Little b is 9. Sine A is 135.29 over sine. What did I do? Correct. No, that's good. That's good.
Sine B should be 20.
Yeah, I thought I messed something up for a second. We're good. All right, so punch that into your calculator and you should get 18.51. And we'll do it again for A2. Same exact steps, just the other angles. So set these part equal to each other from the formula or the theorem. Isolate A2. A2 will equal B sine A over sine B. Of course, these will be 2. Right, this is 1. So that is going to be 9 sine A2 is 24.71 over sine 20.
So you can use B1 from the other triangle to solve for a side from the second triangle?
Yeah, so we use everything from the second triangle to solve for the second part. So we
Oh, because B2 is 9 as well. right?
Yeah, B's
Okay.
didn't change. So usually those stay fixed. The stuff they give you is not going to change. But the missing parts have the potential to have two different answers. Okay, let's see what that is. Got 2 point. Wait. Wait a second. Shoot. Let me double check something. First triangle is good. Second triangle, I messed up here. That should be 4, not 24. Let me double check here. 180 minus 20 minus 155.29. It's 4.71. I don't know where the hell I got. I guess I must have copied this by accident. Weird. Okay. So this one's wrong right there. There we go. Only thing that changes is this last step here. So we're good. Not a big deal. I was afraid I have to erase like 2 lines or something, but we're good. There we go. So there should be a 4.71 in here. Okay, so this would be 2.16. 2.16. There we go. Yeah, the angle was too big. It wouldn't be a triangle if it was 24. All right, so are there any steps that don't make sense? These are the pieces we found for the answers. These pieces. Weird. All right, guys. Guess we'll stop here for the day. You guys have any questions on 9.1 or law of signs?
Can you just fill in all the numbers up top where you made the like organized list up there?
Yeah.
Okay. Yeah, I just wanted to see that real quick.
Sure. Let's see if I can find one. Yeah, another way you can tell if there's no triangle here, let me show an example from the book before you go. Example 3, there's no solution, right? So notice how they get sine A greater than 1. So if you have you know that sine is, that the biggest it can be should be 1. Lowest it can be is -1. So if you say something that's contradictory, that's already telling you it's false. And if you were to try to do sine inverse of this guy, which is how we've been doing it, you would get an error. So if you see an error or you see a statement on paper that's false, then that should give you hints that there is not going to be a triangle. Okay. And when you check for 2, if one of the angles that you solve for, one of the alternate angles don't work, then that tells you there's only one. So there's 2 ways to see, is it not 2? If it's not 2, it's going to be 1. And if I'm solving something and I get an error, it's going to be none. Okay? And you'll start to see that as you're practicing. Anyway, we'll stop here then. If you guys have any questions, you're welcome to stay a bit. If not, I'll see you Wednesday.
Thank you, sir.